Hey there, it's Jason Gorman from Codemanship with the final video on my series on GPT-4 and ChatGPT. And what I'm going to do in this video is just really sort of lay out my final thoughts on my experiences using GPT-4, both in software development and in other domains, and also some thoughts about where I could see myself really using it on day-to-day, and finally some very speculative layperson's thoughts about where this might be heading. Okay. So in this video, I'm going to talk about my adventures in programming with GPT-4, plus other little adventures. We're going to sort of give you a layperson's overview of what GPT-4 is, because I am a layperson, I'm not an AI researcher, but I think I've got enough of a handle on kind of sort of what it's doing or how it works. I'll discuss some of the limitations that I encountered when using GPT-4 in programming. I'll talk a little bit about where I think it might help me and therefore it might help you in software development, and give you some tips on some of the things I found are good ideas to do when you're using it, to get more out of it, basically. And we'll speculate at the end about where this might all be heading. What is the future of AI-assisted software development? Okay, so let's talk about my adventures in programming using ChatGPT and GPT-4. So a bunch of different things that I've tried over the last few weeks. I spent quite a lot of time with it, so I've got to know it a little bit. Did some pair programming and test-driven development in one session. The video is up for that already. In one session, I was navigating and it was driving, so I was telling it what to do and it was writing the code. That kind of sort of went okay, but it took a long time to get 3 tests passing. Flipped the tables, turned the tables, and I had it navigating, telling me what to do based on a description of some requirements. And then I was writing the code, again, the results of that were okay. I will say, even if I say so myself, the code that resulted from it was much better. But we got results and we got test passing, etc., etc. So it was an okay kind of a session. But again, it took a long time. I was interested to see how it handled refactoring. I'd seen some videos of people using it to refactor stuff, so I thought, well, let's give it a go. So I did one of my refactoring exercises, a legacy code exercise called Guitar Shack in C#, and again, the results were okay, but it needed a lot of coaching and a lot of steering. But it can kind of sort of do refactoring. It can. I was very curious, so I'd read somewhere and I'd seen some videos of people claiming that they'd given it sort of sketches of user interfaces and it had generated web pages or generated applications for them. Now, I don't see how that is possible with GPT-4 because that's just not available at the moment. I think I've seen a demonstration of it by OpenAI when they launched GPT-4, but it's not out in the wild yet. It's not available to the public, so I don't know what these people are talking about. When I've tried to sort of link to images in chats with GPT-4, if there's text in the URL, it will just make something up, and it might be a good guess. If it's like mountains or something in the name of the JPEG, it'll say it is a beautiful mountain with a lake and blah blah blah. So it kind of hallucinates a description of a picture for you, but actual pictures, no. For example, when I tried to do it with GPT 3.5, because GPT-4 refused to do it, and when I tried to show this image here of my mock-up of a user interface, GPT 3.5 told me that this was a weather application. This was a weather chart, so it just made it up, basically. But anyway, I was interested to see whether I could describe a wireframe of a user interface, where if I could describe it accurately enough to have GPT-4 generate HTML and JavaScript for me. And again, it was a long session, but we kind of sort of got into the ballpark. So that was a very interesting session. It took a long time to actually figure out how to describe this sort of mock-up of user interface. But we did kind of, in the end, get into the ballpark with lots of remedial work and rework and corrections. So it can sort of do it, but without that ability to just feed it an image and say, go on, generate that for me, I can't see it being a huge help, to be honest with you. What else did we do code-wise? So I was interested to see how it handled more complex business rules. again, very often I've seen videos and read blog posts by people who claimed, oh, I told it to generate a Space Invaders game, or I told it to generate a browser extension, a Chrome browser extension, and it just did it all for me. And I'm really very, very skeptical of this. And one of the things I'm very skeptical of is in real software development, the requirements are not make me a browser extension. The requirements are not make me a Space Invaders game. They're not a single sentence or a small paragraph. Typically, business requirements for software or user requirements are very, very specific. So I thought, well, let's give it something very, very specific and see how it gets on. So I gave it a bunch of business rules. It generated some code for me that was really horrible, a big function with nested if statements and so on and so forth. And then we spent quite a lot of time trying to refactor it. I got it to generate some tests for me. All the tests were failing for all sorts of reasons. I could see that many of its expected values were wrong. It had calculated them wrong, but it didn't seem to be able to see it, and I wasn't about to tell it. I wanted to see if it could spot what the problems were. So this was quite a long first session. I spent about 90 minutes with it. We got to a point where one of the limitations of GPT-4 at the moment is you could only have a total of 25 interactions with it in any 3-hour window. So you only get limited access to it. And we got to the end of our allotted access within about 90 minutes. And what I had was code that was horrible and didn't work. All the tests were failing. So I got up the next morning. This is one of the sessions I decided to continue. I got up the next morning early, and I completely rewrote the implementation myself in an object-oriented style, which vastly simplified the code. And then I got it to regenerate the tests based on this new model, this new design. And first pass, half the tests failed, again, mostly because the expected values were wrong. One was failing because of a syntax error that was my mistake. This is one of the dangers of dynamic languages. But most of them were failing because it got its sums wrong. But we eventually did manage to fix it, and we got all the tests passing. And then we carried on in the session sort of looking at different ways in which we could sort of work with this code. I was particularly interested in how good the tests were, because there was about a dozen tests, and I thought, is that enough for these complex interlocking business rules? So we had a discussion that eventually led us to mutation testing. So I ran some mutation testing on the code to see how good our tests were. It found quite a few gaps in our mutation coverage. Our mutation score was about 57% or something. But I was pasting in the results of mutation testing into the GPT chat window, and obviously it has not seen these things before, because it started to hallucinate badly. It was making up its own mutation scores. It was making up its own surviving mutants. It was referring to mutations in parts of the code that don't exist. So it was kind of rewriting the code in its head. So we hit a hole in the Swiss cheese of what it knows, where it obviously doesn't know very much about the results of mutation testing, the output from a tool. In this case, it was MutPy, mutation testing for Python. It just didn't seem to be able to handle the results of that, and eventually started to refuse to discuss it. It would give me general advice about mutation testing, but wouldn't discuss the report, and kept claiming it could not interpret the results of reports generally. So I think I upset it, in inverted commas. Anyway, it was a very interesting session. In short, no, it can't handle complex business rules. It tied itself in knots, and it wrote some pretty crappy code. So some varying experiences. I've spent a lot more time with it on programming tasks and other stuff. So I've got, I guess, about 30, 40 hours experience with it now. Either using it myself or using it with people I've been coaching and pairing with. And, you know, how helpful is it? We're going to get to that. I will observe that in most of the sessions, I think it took longer to do it with GPT-4 than it would have taken to do it myself, with maybe a couple of exceptions that we'll come to. Right. So that's all good, about coding, but GPT-4 is general. It's been trained on text that relates to lots and lots of different things. And I had heard that it has quite the sense of humor. It's quite the wit. Um, so I asked it to tell me a joke about a duck and a spoon. I didn't ask it to give me an existing joke, because then I would be testing its delivery, and it's very difficult to measure delivery when it's just text. So I asked it to essentially make up a joke about a duck and a spoon. That was very revealing. That was very revealing. One of the things I noticed is it started just with bad puns with words, like quackers and quacktastic, and every punchline ended up with an exclamation mark, as if that makes it funnier. So I tried to steer it away from that, as I did with code. I tried to coach it and go, please don't use puns. And so for the next couple of responses, it didn't use puns. It tried to do something. It tried to make some sense of the fact that it's a duck and a spoon. So I thought, okay, it's learning. But then I gave it more instructions. So I sort of gave it some advice on, the structure of a joke, misdirection and surprise, and how there needs to be a surprise in the punchline, but it does need to tie back logically to the setup. And I think in giving it that advice, so here's what I think is going on. I think there is a kind of a statistical gravity within the conversation. So the most recent thing you tell it is the thing that it, in inverted commas, I'll say that now, that it listens to most. The thing that has the biggest influence on its response. So when I gave it some more advice, it went back to doing puns. And I've seen this both in code and in other things I've tried to do with it, that it kind of drifts back to what it was doing before. It doesn't learn, not in the sense that we know it. It doesn't learn. It can incorporate the context. But I found with code and with jokes and with all kinds of things, it kind of drifts along in the sense that the most recent thing you tell it is the thing that it seems to influence its responses the most. So it doesn't hold in a lot, can't take in a lot, but at the same time, it can do really impressive things. But anyway, no, in short, yes, it can tell jokes, but they're not funny. Yes, it can tell jokes, but they're not funny. So I thought that was interesting. Let's try it on something else. So someone said that they did the crossword with it. So I tried it on a simple crossword, an easy, quick crossword, and I was quite impressed with the results. So I thought, okay, how good is it at cryptic crosswords? The answer is not good, not at all. Not at all. Not only does it not get the clues, and not only does it make up its own justifications and sometimes its own meaningful words, but also, as we're about to discover, it can't count. So if you say it's a six-letter word, first letter is B, third letter is N, it's got no idea what that means. It has no concept of first and third, and no concept of six. So I found that after a while it was spitting out 7-letter words and putting completely different letters in the places that I told it they were already letters, and so on and so forth. So in a word, when it comes to cryptic crosswords, terrible. So yes, it can do crosswords. It's just not very good at them. Okay. And another thing that I'd heard about is that it was good at sort of logic games, like Go, for example. So I thought, well, maybe it's good at chess. So I played it at chess. And again, I was initially very impressed, just as I was impressed when it did the easy crossword, just as I was really impressed when it generated Python code that did what I kind of sort of did, what I told it to do. I was impressed. And we had quite the game. We got up to about 19 moves, so it didn't roll over straight away. And every move it made was legal. It was obeying the rules of chess. It was making legal moves, and I thought, this is really interesting. But I beat it pretty easily. And I did find at one point, I could see checkmate for me in 3. I could see how I could get mate in 3, which is what you're looking at here. And I thought, surely it can see that. Surely it can see that. But it did the move that it shouldn't do anyway, and it was mate in 3. And that's when the kind of the penny dropped, that there's something else going on here. GPT-4 is not doing what I think it's doing. There's a kind of illusion going on here. And I began to see through it. So I played another game where I didn't make legal moves. I cheated. And it seemed perfectly happy with that. And in the end, I got bored and I just told it I had won. I just said, okay, you know, queen to d4, checkmate. Which it wasn't. If it had known where the pieces were, it would not have. It would have been impossible. But it didn't know where the pieces were. This was the revelation, and it congratulated me for winning the game, and that really, really opened my eyes as to what's really going on behind the curtain here. Anyway, so I played chess with that again. Can it play chess? Kind of, but it's not very good at it. Right. So let's talk a little bit. Now, I'm not, as you're about to discover, an expert in machine learning or in large language models, but I do have a background in physics, and I know a lot about statistics and statistical models, and obviously I am a computer programmer, so I know a lot about that, and I know a little bit about languages and grammars and linguistics, the stuff that you would learn at school, for example. I kind of have a layperson's understanding of what is going on underneath. And the question that I'm going to ask in this part of the video is, how has a predictive text engine fooled us into believing it understands things? That's really what this is about. So what is ChatGPT? What is GPT-4? Well, there was a game show, a quiz show on the BBC here in the UK, whether they have it, I'm sure they have it in other countries as well, called Blankety Blank. And the idea is that you've got two contestants, and then you've got a panel of 6 celebrities, and each contestant is shown a statement in which there is a blank. There is a word or words left out. And they have to guess what word or words should go in that blank. And so do the celebrities. So 6 celebrities, they also have to write down their guesses. And to succeed in this game, you have to pick the word or words that the most celebrities are going to write down. So what is going to be the most popular choice? What is the most popular choice? And that's how you win at the game, basically. You get a point for every match. And the more matches one contestant gets than the other, they essentially win that particular round. Now, if they win their round, they go on to play what's called the super match game, where this time they're shown a word or a phrase that's followed by a blank, or it could be preceded by a blank, and then they have to pick which they think would be the most popular choice from a sample of 100 people. So the researchers ask 100 people, car blank, and then they collate the answers, and then you get the top 3 most popular answers, and then you win a bigger prize the more popular the answer that you choose. And you can ask 3 of the celebrities on the panel to help you, but that's not part of the game. Your goal is to pick the most popular answer, the answer that is the most likely to go in the blank. That is essentially what ChatGPT, what GPT-4 is doing. That is effective. Obviously, it's a lot more complicated than blankety blank, but you are, to all intents and purposes, playing blankety blank, or it's playing blankety blank. You might be coding, you might be playing chess, you might be writing an after dinner speech, but it is playing a game of blankety blank. And you don't win at blankety blank by being clever or by being original or by being brilliant. That's not how you win at blankety blank. Now, of course, this comes in with context. So within conversations with GPT-4, there is context that constrains its responses. So car could be followed by car seat, car lot, car radio, car park, etc., etc., etc. But a multi-story car, now we have far fewer choices. So what comes before the last token will constrain what can come after. And that's what happens when we're prompting GPT. We are constraining its responses. We are constraining the choice of what they, OpenAI, call tokens that can come next. So in the sense, you can kind of coach it to produce a less probable response. But in terms of the complete sequence of text, the complete sequence of tokens, words, and characters, that what it's trying to do essentially is to maximize the probability of the entire sequence, including its response. That's essentially what it's doing. Now, how does what is effectively a predictive text engine, something that is playing blankety blank, it's just trying to guess what word comes next, how does that fool me into believing that it can play chess? Because when I was playing it, I genuinely got a sense that there was a mind behind the screen, that it had some internal model of the game. It knew where the pieces were. It understood the rules. It was evaluating the strength or weakness of each move. It was looking ahead, maybe 3 moves ahead or 4 moves ahead or 5 moves ahead, or in the case of a real chess computer, many more moves ahead. It was looking ahead and sort of weighing up which of the next moves would give it the biggest advantage. And I genuinely got the sense that's what was happening. And the way that we were communicating was through the short abstract notation that's used by many chess players to describe moves. So if I want to move a pawn to d3, it's just d3. If I want to move a knight to f3, for example, then it's capital N f3. So you can express moves in a very succinct form. And what's interesting about this, because I think what's really dazzled us with GPT-4 and other generative AIs, what's kind of fooling us into thinking that it really thinks, it's a real mind, is the sheer complexity of our language, of our spoken and written languages, like English and French. So we cannot see the wood for the trees. When I stripped all that away, and it just came down to chess moves, simple, deterministic, and in this case, legal sequences of legal moves, it became much more apparent what was going on. Now, I want you to think a little bit about event sourcing. Event sourcing is a style of software architecture where we don't, for example, store a bank balance. We store the history of transactions against that balance, and we're able to recreate the actual balance, the state of that bank account, by replaying that history. In other words, the sequence of events, the history of that bank account, is equivalent to the state of that bank account as it is now. A chess game, as long as all the moves are legal, is the same if you think about it, or to a certain degree, to a point, it's the same. If we're working through a sequence of legal moves, that sequence is equivalent to, if we replayed that sequence, it would give us the current state of the board, the current location of the pieces. So the history of the moves being equivalent, if you like, to the state of the game creates the illusion in my mind that there's another mind at the other end that is looking at the board, is looking at the same board as me, has the same internal model of the game. It doesn't. It just has the history of the moves. And it's just predicting which move is the most from the data, from the sequences of moves it was trained on. And I can imagine it was trained on millions and millions of sequences of chess moves, millions of chess games, because there's so many resources out there, so many websites and books, etc., that it is essentially, it's replaying a game or a statistical approximation of a game, or several games, if you like, sort of concatenated together, that it's been trained on, asking the question which move should come next. It doesn't know whether that most probable next move is a good move or a bad move. It doesn't know. It doesn't understand. It doesn't plan ahead. It cannot evaluate the moves. But if it's been trained largely on legal moves in chess games, there's a chance that the moves will be okay, but it doesn't know whether it's going to win or lose. It doesn't know in the data that it's been trained on whether that next move was part of a sequence of moves that led to a win for that player. It has no idea, as far as I'm aware. So it can't tell good moves from bad moves in the same way that it can't tell funny jokes from not funny jokes. And it can't tell good Python code from bad Python code. But because it's been trained, think about this, because it's been trained largely on code that is syntactically correct, that is well formed, it will produce code that is well formed and that is statistically closely related to the instructions we gave it, the words we gave it, the problem domain, if you like. So that's how it fooled me into thinking it was really playing chess. It was doing what I was doing, And that's how it fooled me into thinking it really knows how to write Python programs and JavaScript programs and how to refactor C# code. It's the same effect, but as the complexity of the language increases, the harder it is to see the wood for the trees, the easier it is to be fooled, to fool ourselves. There's this whole idea in consciousness studies of theory of mind that we developed. It's one theory of evolution of consciousness, is we develop consciousness so we could put ourselves in someone else's shoes. Can that can that gorilla see me from behind this tree, etc., etc. Theory of mind. And I got fooled when I was playing chess with it, and I could see mate in 3, and I was genuinely thinking, it's bound to see that. It's bound to see that. Nope, it sees nothing. It understands nothing. The emperor has no mind. So I'm very glad I played it at chess, because that kind of peeled back the curtain, and now I know that there is no magic to the Wizard of Oz here. It is literally a massive, a very impressive, massive, hugely interconnected predictive texting artificial intelligence, if we could call it that. Because if you think about it, the intelligence that's built into it, on which it was trained, is the wisdom of crowds, the wisdom of millions of chess players, the wisdom of hundreds of thousands or even millions of Python programmers, which is probably why by default its Python code is so bad. But it compiles and it runs. And we shouldn't be surprised that its code compiles and runs, because it will be largely trained on code that compiles and runs. Whether it's right code or wrong code, or whether it's good code or bad code, it doesn't know, in the same way that it doesn't know whether that's a good chess move to make or a bad chess move. It has no idea. It's just the next most probable move based on the data, the sequences of moves that it was trained on. Okay, it doesn't discern at all. So that kind of is what I've discovered about GPT-4, and it's taken me a long time to sort of see through it. Or at least I think I see through it. So, but I still have to remind myself that there's nobody at the other end of this conversation. There is no mind. And I'm going to have to continually remind myself, because it's so easy to fall into that trap. Okay, now let's talk about where it can do impressive stuff for a predictive texting engine, albeit one on a massive scale. It is very impressive, but there are times when it will do things that just make it look stupid. So let's talk about some of its limitations. Okay, now this is one that I'm guessing at, based on my understanding of large systems and statistical mechanics, and the way that I understand large language models work. When you're playing blankety blank, which is essentially what it's doing, when you're playing blankety blank, you don't win by being original or by being clever or by being brilliant. You win by being as average as possible. It's trying to guess the next most likely token in the sequence, the next most likely token. And so I have a feeling, and I'm kind of seeing this at the moment, because I've seen all kinds of hyperbole in the press about, oh, it plays superhuman chess, and it does this superhuman, and it tells superhuman jokes. What I've seen of it, it is a below average programmer. It is a below average joke teller, a below average humorist, if you like. It is a below average crossword solver. It is a below average, well below average chess player. And I think the more data it's trained on, it's not going to get expert. If you train it on 10 times the data, the Python code, it's not going to get 10 times as good at writing Python code. I think it's going to get 10 times as average at writing Python code. That's what I think is going to happen. We can talk later on about how you might be able to get around that, how you might be able to lift that average. But certainly in the way that GPT-4 it was trained, which is basically it read the internet, that's good and bad. All the good chess moves and all the bad chess moves, making it at best average at chess. Right now it's below average. So I think from a purely statistical, mechanical, physicist point of view, the limits of GPT-4 are it can eventually one day be average at best at everything to do with language, anything that could be expressed in language. Okay, so bear that in mind. Right, as we've discovered, it cannot count. It revealed that when we were doing crosswords. It revealed that when it was trying to generate expected values for test data. It cannot count. This is one of many things it cannot do. So be very careful when it gives you when it's working with numbers in particular. Be very careful. But there are all kinds of things, in actual fact, it cannot do. It has no concept of time, for example. It has no spatial awareness. So there are all kinds of intelligence it does not possess. Now, there are many researchers who are saying, well, it can be augmented. We can have a hybrid AI where something like GPT-4 or 5 or 6 is a natural language interface to other artificial intelligences. So it'll be interesting to see how it can interface with these other intelligences, because it is interfacing with lots of intelligences, namely us. And what I've discovered is that doesn't necessarily go so well. You have to really, really coach it. I don't think it's going to be a question of having, for example, a chess computer telling it what to do, because I don't think it's going to be as simple as that. But that's one of the areas that I think they're going to explore, is how can things like machine vision and chess computers and stuff like that, how can that be built into an ecosystem of AI kind of tools with a natural language interface. But that's a very different route to artificial general intelligence than the one that some people are claiming GPT-4 is the beginning of. There are some people out there who are claiming it is eventually going to become artificial general intelligence. I think it has fundamental limits. I think it has fundamental limits, and it will never, as far as I'm concerned, become a super intelligence. It will always only ever, at best, the way they're currently doing it, be average at lots of things to do with language. Okay, so it can't count, bear that in mind. Data generally, don't trust it. It is a bit like a goldfish in the sense that it does quickly forget. I think there is some kind of statistical gravity going on here between things I told it 3 interactions ago and things I've just told it. So when I was trying to get it to tell jokes about ducks and spoons, it kept using puns, and I said, don't use puns, please. And then in the next joke, it didn't use puns. And I said, but it did something else. The punchline had nothing to do with the feed line. So I said, should the punchline be logically related to the feed line? So it went, yeah, oh yeah. So then it did that, but it went back to puns. So I think what you've told it most recently seems to have the biggest statistical pull on what it decides to respond with next. And that means the conversation kind of drifts. It is a bit like talking to a goldfish, to some extent. It remembers certain things better than others. But I have noticed, for example, that over time, its understanding, in big inverted commas, because it doesn't understand, but its understanding of the code that we're working on drifts away from the actual code. And I don't think that's to do with the limited context window, because that's like a hard line. Something you told it 8,000 tokens ago, it just forgets completely. But yeah, you do need to be very careful with it. I found myself quite often having to remind it of what we'd already discussed, or having to show it the code again and stuff like that. And finally, just remember, it doesn't understand anything except statistical relationships between words and text. That's all it understands. It doesn't understand chess, doesn't understand Python, doesn't understand solid principles, doesn't understand the world in any way, shape, or form. It doesn't think, and it doesn't understand. The emperor has no mind. Okay? So please remind yourself of that when you're working with it. It's not thinking, it doesn't understand, it's going to make all kinds of basic mistakes, because it is, at the end of the day, a massive, highly interconnected predictive texting engine. That's what it is. It's playing blankety blank with you. And those limitations become very clear the longer you spend with it. Okay, now, having been pretty negative about it at this point, I think we're going to try and come up with some positives. So there were some useful things that it did for me, I have to say. There were some times where I thought, actually, that's pretty useful. Even though most of the time I came to the end of a session thinking, first of all, came to the end of most sessions not having been able to complete the task and hitting that limit on interactions in the 3-hour window. But also quite often with the distinct feeling it would have been quicker if I'd done it myself. They felt like coaching sessions. It felt like I was coaching someone who very quickly forgets what I've just told them. So very frustrating in that respect. But there were times where on sort of self-contained, one-shot kind of hit kind of things where I thought, yeah, actually that was useful. So let's talk about those. First of all, when I was trying to create this little web page with it, with the monthly calendar view, I wasn't quite sure how I was going to do that calendar view, so I just asked it to generate some code to do that for me. Now, I did not like the code that it generated. There's business logic embedded with HTML there and all kinds of nasty things going on, but it did at least make me take a look at it and go, oh, okay, that's how you do it. Right, okay. And then if I was doing it for real, I would have read it, I would have tried to understand it, and then I would have sort of done my own version of it. So I did find it useful for that. So that relegates GPT-4 into a kind of Stack Overflow plus role, a kind of how do I do this, how do I do that, how do I connect to a MySQL database over this kind of network and so on and so forth. It's good at that. And it's no surprise that it's good at that because it basically ate Stack Overflow, all the good stuff and all the bad stuff, of course, as well. It ate all of that, and of course, it ate all of the contents of the public contents of GitHub and many other code sources that it could get its hands on. So it is useful for looking stuff up. Okay. You of course need to be very wary of what it produces. I did actually find it useful when I was working on my own to have someone to bounce things off. It's sometimes referred to as rubber ducking or rubber duck debugging, when you're stuck on something and there's no one to help, there's no one who can sit down with you. So you get your rubber duck or your inflatable parrot or whatever it is, and you explain to it what the code is doing, what the bug is doing, what it's supposed to do, etc., etc. And quite often people find that the act of explaining it or trying to explain it means that they kind of get that epiphany moment and think, oh, that's what it is. I've had it many times, and I did find that sometimes when I was using GPT-4, it was useful in that kind of role. Again, it doesn't really matter whether it answers back or not, but it is useful that it does. Now, remember, GPT-4 has no intelligence. What it has is a statistical model of the products of millions of other intelligences. It ate the internet. So millions of lines of Python code, for example, or millions of chess moves. So when you ask ChatGPT, you are essentially asking the internet. It's the wisdom of crowds. And that can be a useful thing to bounce off. So I did find it helpful in that respect. But again, you need, just as it is with a real person, you need to double check everything and take it with a pinch of salt. I often find the act of explaining is much more useful. So, rubber ducking can be useful. Now, it's been mentioned by a lot of people I've spoken to about GPT-4 that they say they found it useful for writing repetitive boilerplate code. Now, I make the argument that if the code's very repetitive, that's a different problem that needs solving. But I can kind of take that on board. And one example that I've sort of had floated is persistence code. So if you've got an object-oriented domain model and you want to persist that to a relational database, that's such a pain to do all of that and write all of that persistence code. And so that I thought that might be a good example to do, to demonstrate. So I was going to do that this morning. I created a little JavaScript domain model, just 4 classes, a hotel that has rooms and guests and bookings. No fancy stuff going on like inheritance or polymorphism or anything like that. And I said, look, could you generate for me a code, SQL for a MySQL database to store these objects, and then JavaScript to persist these objects, so that I could demonstrate for you in this video an example of GPT-4 being useful at generating boilerplate code. What did it do? Of course, it did it really badly. It put all the data access code inside the domain objects, including the embedded SQL. And so we ended up having another coaching session where I tried to get it to do the way I thought it should be done. And eventually it did introduce repositories and the unit of work pattern and other stuff that I would have probably done. But it took me, a good 45 minutes to get to a point where I had something that was half decent. And I thought, this is a really bad example because I essentially wrote this code. At least I told it what code to write or what to do. So the jury is out on boilerplate code. I would need to see that boilerplate code to know whether or not it's a good thing or a bad thing. Certainly having a tool that is really good at generating lots of repetition in your code, I see as a bad thing in the long run. You want tools that make it easier to write code that's going to not hurt you later on. So yeah, the jury's out on that. I'm not entirely convinced that the ability to generate repetitive and boilerplate code is quite the bonus. And one, I'm not convinced that it can do it well enough. And two, I'm not convinced that it's not a poisoned chalice that it's handing you there. Okay. Now, if you are going to use GPT-4 in programming, and why not? Because I do think, after everything I've said, I do think it is worth the $20 a month just for the Stack Overflow++ feature. But if you are going to use it, you need to be very clear and specific about what you want. And this is hard. We all find this hard. So prompt engineer, I think, is a job title that's going to start appearing more and more because there's a real skill to it. You need to spend a lot of time practicing it. Take small reversible steps. Don't go in and go, well, make me a game, and then copy and paste that game. Give it a small thing to do, just a few lines of code, maybe 10 lines max, like you would do it for real if you were doing it, I hope. Don't just copy and paste from the chat window into your code. Number one, that starts to get really fiddly. But number two, that's like eating code. That's like eating code you picked up off the street. You don't really know what's in it. You don't necessarily understand it. And you may be required later on to change it, particularly if you're asked to make a change and you run out of your 25 interactions within a 3-hour window, then you're going to be editing code. So you do need to understand it. So I'm very much in the habit of not copying and pasting, except for these little adventures I've been having with GPT-4, but if I was using it for real, like for that calendar view, I would read its code, I would try to understand it, and then I would make it my own. It's got to go in my eyes, through my brain, and out my fingers, basically. Especially if you're a junior programmer or you're starting out, by far the slowest way to learn is copying and pasting code. Okay, test continuously, so just keep testing it. A lot of the code that it writes will not work, I promise you now. So keep testing it and double check every fact, every number, every name, every list. Double check every fact. It makes stuff up. And finally, remember that it doesn't learn, it can't learn. The time that it learns is when it's being trained. You can refine it to include, a model of your data, but it doesn't really learn, and in longer sessions it can drift like a goldfish reading a newspaper. What was that last paragraph about? It can drift away from you over time. So get into the habit of feeding that back in. Now, better integration, tighter integration with development tools might help. We'll have to wait and see. What I've seen so far with integration with things like VS Code is all they've really done is they've brought a version of the chat window into VS Code. So that's not really what I'm thinking of. You're still copying and pasting. What I'm hoping is the integration will be much, much tighter than that, and you won't have to keep showing it the code. It'll know what the current code looks like within that context. Okay, but that might not be happening with GPT-4. We still might be in the world of copy and paste. We'll have to wait and see. Okay, and talking of waiting and seeing, finally, I just want to talk about where I think this might be headed. What is the future of AI assistance in software development? And you're going to find that I'm going to be a little pessimistic here, and then hopefully finish on a more optimistic note. So I apologize if you're one of the many true believers out there who believe that GPT-4 is the beginnings of artificial general intelligence, and if you're one of the people who believe that we're not going to lead programmers in 5 or 10 years' time, I'm afraid I'm about to disappoint you, and you're very welcome to argue with me in the comments. I am, of course, right, and I appreciate I am going to look like the biggest idiot after what I'm about to say if 5 years from now I'm making videos about training to be a plumber. But I have a feeling that's not going to happen. So anyway, let's talk about the future. First of all, let's talk about the low-hanging fruit. Much tighter integration between tools like GPT-4 and our day-to-day development tools, I think is probably possible. Certainly, it must be able to improve on it, and I think that will make a difference to its usefulness in that sort of Chat GPT ++ role. So that, I think, would be a good thing. I'm looking forward to trying Copilot X, one of the many things I'm looking forward to trying. But for now, we're in the world of copy and paste, and that's really awkward and error prone. So I'm looking forward to much tighter integration with, I'm very much a JetBrains user, so if you're listening, JetBrains, much tighter integration with GPT-4 would be fantastic. Or Copilot or whatever it becomes. I'm looking forward to being able to show GPT-4 pictures of user interfaces and saying, give me some HTML for that, please. I'm looking forward to finding out if it even works. That would be the first step. But I think that actually would be very useful to be able to take prototypes, e.g. whether they're just wireframes or PowerPoint knock-ups like this one, or even pencil drawings or things from more sort of high-fidelity prototyping tools for user experience design. I think that would be a useful thing. So I'm looking forward to trying that. I can't comment on whether it would be useful or not, but I'm looking forward to trying that. So that's kind of the near future. In the less near future, we really need to talk about how these models are trained. Like I said earlier, the problem with GPT-4, and presumably with future versions where they're promising that it's going to be trained on orders of magnitude even more data, is that it's not selective enough. It's been trained not just on winning chess moves, it's been trained on losing chess moves. So I think maybe the future lies in not having these giant general purpose models, but maybe having much smaller and much more selective models where they've basically trained it on all the good moves, all the good chess moves, or all the better Python code. So maybe we need to have a system whereby it's only trained on Python code that we know has passed tests, that we know has made it through some kind of code review by, whether it's automated static analysis or a peer code review or whatever it is. So we need this idea of code that is trusted, chess moves that can be trusted, jokes that are funny. I sort of quipped when I was discussing this on social media, maybe when it comes to humor, it needs to be trained in front of a live studio audience, because it has no idea whether its jokes are funny or not. It claims they are. It told me it was a great wit, on a par with Douglas Adams. I beg to differ, but it's not GPT-4's fault. Remember, it has no mind. It doesn't know whether it's funny or not. It doesn't know what that means. So there are ways in which we could be more selective, whether it's only including code that's demonstrably passed its tests, etc., whether it's only being trained on the good stuff, if you like, and probably only on the good stuff in one particular problem domain like chess. But that kind of brings us back to it being essentially just a natural language interface to smaller, much more selective models that are essentially giving it the results and saying this is what you need to give back to the user. So I think that might come in the future. I am reading that there are some companies like Bloomberg who are beginning to sort of get the message on this, that no, actually the problem with GPT-4 is it's too general, too much data, all the good stuff, but all the bad stuff as well, and there's no way to differentiate. So when we talk about it, eventually sort of converging on average, there is a way potentially that we could raise that bar for average in a particular problem domain. But that bar will be different for different problem domains. So I think that will be at odds with having a general purpose language model. So I think we're going to have to choose, basically, in the future. Anyway, so yeah, better data, basically. So these are things that could be done, that we could start doing now. I don't think they're things that OpenAI are planning to do, but I see other companies that are sort of getting into these territories now that have plans to be much more selective about data, training data. In terms of the future itself, let's get a bit more general now. what I'm reading at the moment, the hype that I'm reading about GPT-4, about large language models in general, and about AI in general, is all mostly predicated on the idea that this is an exponential growth curve, that these AIs are just going to get more and more and more and more powerful, that we're going to train them on 10 times the data, 100 times the data, 1,000 times the data, and it's going to be 10 times as smart and 100 times as smart and 1,000 times as smart. Now, as a physicist, I know that that's impossible. It's statistically impossible. There are real physical limitations in terms of energy, compute power, information theory, all kinds of limitations on just how good, for example, a large language model can get at something. Like I said, it will only ever tend towards the average of the data that it was trained on. So you need to somehow find, if you want a super intelligence, you have to find data to train it on that comes from a super intelligence. You need super intelligent data. You need a far more intelligent crowd to draw that wisdom from. And I think what's going to happen is large language models are taking those as an example. I think they're over multiple versions as they get trained on more and more data, and as they feed on each other's outputs more and more. I think we're going to experience a kind of heat death where they all just reach equilibrium, basically are just a huge sea of mediocre. Is what I predict the end point of LLMs in particular to be, because it's intrinsic to their architectures. It's intrinsic to what they do. Remember, you don't win at blankety blank by being brilliant. It's not a game for super intelligences. It's a game for the most average people. And the more average you are, the better you will be at the game. You can raise the bar for average, but who is going to make those discoveries? Who is going to make those discoveries? I'm not at all convinced. I've seen nothing original from GPT-4, or that I would call original. I've seen merges of different sources of information. Can you please, for example, explain large language models in the style of Victoria Wood? But what it does then is it's just choosing words statistically. So because the words Victoria and Wood are right next to each other, it's going to insert words in its response like custard creams and stuff like that. It doesn't understand what it's writing. It's not writing new Victoria Wood material. It's certainly never going to be as funny as Victoria Wood, who is, let's face it. But it can make a decent fist of sounding like Victoria Wood. It's like one of those impressionists, television impressionists from the 1970s, who instead of having any kind of original material, they would put on a costume or a moustache or whatever to try and look a bit like the person, and then they would try to make a voice that sounds a bit like the person, and then instead of having any material, they would just say the person's catchphrases. And that's kind of what GPT does. If you ask it to explain general relativity in the style of Frank Spencer, a comic character from the 1970s that was a popular impression then. If you ask it to explain general relativity in the style of Frank Spencer, it will explain general relativity and occasionally say something like, "Ooh, Betty," or "The cat's done a whoopsie." It's the same thing, basically. So am I convinced that what we have in terms of transformers, this technology that's only recently appeared 6 years ago, I think, are transformers the path to artificial general superintelligence? I'm not at all convinced. I think we are at the start of an S-curve. We're at the start of an S-curve, and because it's the start of an S-curve, it looks like exponential growth that could go on way beyond our dreams. But I think it's an S-curve. And I think investors, we'll talk about those in a minute, I think some of them know that it's an S-curve. I'm not going to say which ones, but there are some investors who have form in hyping S-curves in artificial intelligence. And I think their plan is to hype this S-curve, grow the bubble as much as they can before we realize as end users and before other investors realize that it is an S-curve, that there are limits to this technology, not just in terms of its logical architecture, but physical limits in terms of computing, energy, and all kinds of other things. You know, the brain is a massively parallel, so massively interconnected. And so, as I understand it, are large language models. The difference being that in the brain, every neuron is a processor. In a large language model, you need processors to do the processing, and the language model is kind of separate to that. So not every token in your model or every element in your model has its own processor. So I think they're going to be real. As with all physical systems, these things eventually have to be physical systems. As with all physical systems, there are real limits, and I think we will eventually, maybe 5 years from now, or 10 years from now, or 1 year from now, we will hit those limits. And that kind of reassures me as a software developer that it's never going to get better than average, and that could be bad news if you're a worse than average programmer. But for a lot of software developers, bearing in mind, of course, that software development is also much more than programming, way more than programming. It's a small part of the overall job. I don't think this is going to make much difference. If it does speed up software development a bit, then what we've seen in the past when people have come up with technologies like third generation languages and compilers, like low code and no code, like model driven development, and all of these different and code generation and domain specific languages and AI sort of code generation, all these different technologies over the years. And there's always been some people who've been touting this as the end of the software developer. And every single time, I'm not saying for sure that's going to happen this time, but I suspect it will. Every single time you don't get you don't get fewer software developers, you get more code and more software developers. Third generation languages, we won't need programmers anymore. What we ended up with is way more programmers. And I've seen this pattern repeated many times in my lifetime and over the history of computing. Every time we come up with some kind of productivity boon for programmers, what you end up with is more programs, more code, and more programmers. And suspect if it makes any kind of dent in the productivity of developers in the short term, I think that's what we'll see. Eventually, just more developers, more to develop and more developers. Anyway, that's by the by. There's no doubt that we're definitely in a hype cycle for generative AI at the moment. Where we are in that cycle, it's hard to say, but I think we are potentially moving towards the peak of inflated expectations. So we're just kind of at the beginning of this cycle at the moment. This kind of technology is only 6 years old. And there's massive amounts of money being invested and massive amounts of chatter being generated around, in particular, GPT and OpenAI. So when will we pass over that trough of disillusionment, that peak of inflated expectations into the trough of disillusionment? Now, if, as I believe, we're at the beginning of an S-curve, there's going to be a point where it's become more obvious that this is an S-curve, that large language models, for example, are going to have real limitations, that at best, they just get more average, although you can raise the bar of average, of course, by being more selective with the data. But I'm sort of kind of foreseeing a future where they're essentially just going to start eating each other's output, being trained on each other's output. And thermodynamics would suggest that we're going to end up with everything at equilibrium. So they can't just get smarter and smarter and smarter exponentially. I just don't see how that can happen in any kind of physical system. So eventually it will become obvious, and then, as it was, for example, with offshoring, there was a time when offshoring was very, very popular, and there was lots of people talking about it, and lots of companies were planning to do it. And we reached sort of the peak of inflated expectations, where there were companies springing up all around the world to do development in places like India and Eastern Europe. And then they began to realize that in the long term, it maybe was a bit of a false economy. And maybe they should start bringing their development back on shore or near shore. And so I think we're maybe a few years away from that with generative AI. And of course, I'm going to look like the biggest idiot if it ends up all being true and we end up being ruled by some godlike artificial intelligence. But I'm not entirely convinced that it's going to happen in my lifetime. Anyway, once we hit the trough, that's when the real smarts come in, the real wisdom comes, where we go, well, actually, it's not that it's totally useless. There are things we can use it for, and there are ways in which we can learn how to use it where we get more out of it. So I think there will be smarter organizations, smarter teams, and smarter developers will find ways to use future iterations of this technology to do their job. I don't think it's going to be the sort of morning, night morning sort of after transformation that going from punch cards to COBOL, for example, was. I don't think we're going to see anything even approaching that. But I think it can make a small difference in its current form. Anyway, those people will eventually figure out how to use this technology wisely. They will get some value out of it. I'm already getting some value out of it. I think it's worth $20 a month. If they make it a lot more expensive than that, I might take a view on whether it's worth it, bearing in mind I can usually write code better and faster than it does once you've taken into account all the stuff that needs to be corrected and refactored and etc. So it's not all doom and gloom. I think this technology has its place. It's been a very interesting experience using it. I will probably continue to use it. You may see it pop up in future videos, but for now, this is the end of my adventures with GPT-4 and the end of this series on AI in software development. So you take care, and next time we'll meet face to face, real human beings.